When we talk about a simple circuit, the potential difference or the voltage coming out of the power supply is going to be equal to the voltage going through that one resistor. That one resistor is going to take all of the voltage that the power supply has to offer. That's not the same, though, when we start making complex circuits. And the two types of complex circuits are your series circuit and your parallel circuit. So this is an example of a complex circuit that has three different resistors in it. Okay, it's got resistor number 1, resistor number 2, and resistor number 3. Now, if I set this circuit up to, let's say, a power supply that reads 10 volts, in a series circuit, you always only have one loop. So if you look at this, you'll see what I mean by that. It means there's only one path for the current to go. It leaves the power supply, goes through the first resistor, onto the second resistor, through the third resistor, and back to the power supply. Okay? Now, here's the interesting thing about a series circuit. When one resistor breaks down, the whole circuit stops. It's a fail-safe. Okay, and that makes sense because if, let's say, I've got, my first light bulb lights up, it's all nice and great. Yay, we've got light. Okay, my second resistor here, maybe it's a little piece of ceramic that's just supposed to calm the circuit down a little. If this is not working, if this guy right here decides it's broken or for whatever reason, what ends up happening here is there is a break in the loop. The current can't go from the power supply through the first one. It stops here. It cannot go on. Therefore, the circuit as a whole doesn't close its loop. This is not going to work, and nor is this. The whole thing shuts down if one of however many resistors in the circuit breaks. Case in point, Christmas lights. Okay, if you celebrate Christmas and you've ever put those little mini lights in your tree and one of them happens to burn out, you can have an entire set that doesn't light up. Okay, so you have to go and sit there and you have to check every single light bulb with a new light bulb to see which one it is. That is because those light bulbs are linked together in series. Okay, they're linked in one loop only. If I set this series circuit up at 10 volts, okay, is it safe to say that my first light bulb will have a resistance that I can calculate? Because like any other circuit, I can put in here a nice little ammeter and I can get my current intensity. I already know my potential difference. So is it safe to say that I could calculate the resistance of each of these resistors? Yes, I could. Now, if let's say resistor 1 has a resistance of a certain number, resistor 2 has its own resistance, and so does resistance 3, here's the rule of a series circuit. The total voltage, so V total, that's what the little t means, and that's the V, that's the voltage that's coming out of the power supply. Okay, that is your total voltage. The total voltage is going to be equal to the sum of the three voltages affecting each of these resistors. So it's going to be equal to the sum of V1 plus V2 plus V3. And how we actually measure that is that we would actually put a voltmeter here and it would take a reading. We unplug it, then we move the voltmeter to here and take a reading of resistor 2. Then we unplug that and do the exact same thing to resistor 3. And what we see is that if this is a pi, okay, if this is this 10 volts is a pi, depending on the resistance of each of the resistors, okay, R1 will take up this much of the total voltage. R2 might take up this much of the total voltage, and R3 will take up the remainder of the total voltage. They each get a piece of the pie. And when you sum them up together, when you sum up the reading from this voltmeter, and this voltmeter, you should get your total voltage. Does that make sense to you? Okay, now, the other thing that we measure, and we are going to do a lab on this to prove this. The other thing that we measure in a series circuit is current intensity, right? And the last lab we did, the simple circuit lab, it didn't matter where we put the actual ammeter in the circuit, it gave us the same reading. That is also true of a series circuit. So my current intensity, I total, in this case is not going to be equal to the sum of all the I's. It's going to be equal to the same I everywhere on the circuit. So if I wanted to put my ammeter here and get a reading between the power supply and the first, this would be my I1. Okay, it's equal to I1, which is equal, if I put my ammeter over here and got a reading between I1 and I2, this would be I2. And if I move my ammeter to where it is now, or if I move my ammeter to over here, it's still going to give me the same actual reading. So the current intensity in an actual series circuit does not change. It's the same anywhere you put it in the circuit. The only thing that changes is the voltage that's associated with each of these resistors. And their sum equals the total voltage coming out of the power supply.